My name's Erica Guevara-Blackwell, and I'd like to welcome you to the third event in our Zero Waste Solutions Speaker Series. I am Zero Waste Humboldt's new program manager. Before we introduce tonight's featured speaker, I have a few important acknowledgments, and Maggie has some good news for you. Zero Waste Humboldt wants to thank our generous sponsors for the whole series. That'd be Lost Coast Brewery, Coast Central Credit Union, and the Footprint Foundation. We are grateful to the supporters for this evening's event, which would be Humboldt Traders, Stillman Associates, and the following businesses that provided generous donations of their food and beverages. So thanks to all of you for supporting us this evening. We also will be having a raffle tonight. I hope most of you got a raffle ticket, and we will be announcing the winner at the end of the presentation. And the winner will receive a California Cube box with a six-pack of selection of beer. So hope someone wins and is happy. So I also want you to know that our very first sponsor was Redwood Alliance when we first started a few years ago. We could not hold events like this without the ongoing logistical and operational advice and support of Michael Welch of Redwood Alliance. So thank you, Michael. And then I'd like to ask Maggie to come up for a moment and give a few brief announcements as well.
Grassroots grant from Humboldt Area Foundation, and it's for high school kids. So we're in the beginning stages of zero waste youth leadership development. So we're recruiting 2 kids from, I guess a total of 6 from McKinleyville High, Arcata High, Six Rivers High, and Eureka High. And we want them to be students who will be juniors and seniors next year. And we'll be coaching them and training them to do a project in their own high school campus. And then the big reward at the end is they'll be able to go to the U.S. Zero Waste Youth Convergence in San Francisco. So let us know if you know of some kids who might in particular be interested in this. Second thing is we have a sign-up sheet right over here as you walked in the door. And there's a really great thing that's going to be happening in October. It'll be on a Monday. We're zeroing in on the exact date. The U.S. Zero Waste Business Council will be doing a training for professionals that want to be certified in zero waste. Really know the metrics and the measurement and know what you're talking about and help everybody else. So if you're interested, you know anybody that might be interested, you want us to contact you, we'll give you all the details. Just sign in right there. And let's see. On March 2nd, Wednesday, next week, City Council of Arcata, it's my understanding, sometimes dates change. My understanding is that if you think I'm off on my date, you tell me. The agenda is going to include a presentation from Eel River Resource Recovery about their proposal to process Arcata recyclable materials locally rather than shipping them off down the road. So if this is something that interests you as much as it does us at Zero Waste Humboldt, attend that meeting or send your council members an email and let them know how you feel about that. The presentation ought to be really interesting to you, just how recycling all works. And then the last thing is our presentation coming up in a week, Friday, the 4th, it will be fantastic. It'll be on the HSU campus. We have lots of information. We don't like to hand out swag, but we have some little half-sheet pieces of paper here about it. We've had not always is it printed correctly. So it starts 6:30 is the presentation, 6:30 to 7:30. There is a fundraiser for Californians Against Waste. The speaker is the executive director, Mark Murray. He is returning to his alma mater, so it's kind of a real special thing, and he's an extraordinary representative and lobbyist for recycling and waste reduction issues. So the cool thing for everybody who doesn't come from the campus to that is that there'll be free and convenient parking right across from the location in a nice big parking lot because it's Friday night and it's after 5 o'clock. So you want more details, you just let us know. Thank you all for coming.
So before we get started with this evening's presentations, I'd like to introduce our board members. So if you could please stand up when you hear your name, please. We have Tracy Jordan French is our president. And we have Maggie Gaynor as our vice president back there. Brett Watson might still be downstairs, but he's our treasurer. Brett, not here? Yay. And we have Nancy Stevens at the back. She's our secretary. And then Julie Layshock is our plastics expert, environmental toxicologist. So, please feel free to introduce yourselves to the board members, start a conversation. And now I'd like to introduce Tracy Jordan French.
Confession, Maggie wrote my script, and some of the words are hard for me to pronounce, but the proliferation of plastics in the environment is out of control. Plastics are an increasing and difficult part of the waste we generate. Industry labels of compostable, biodegradable, and recyclable for plastics have contributed to the public's confusion. Our featured speaker, Julie Layshock, will explain the basic chemistry of different plastics to help us understand claims about compostability and recyclability. Dr. Layshock teaches chemistry at Humboldt State University and is active on the Zero Waste Humboldt Board of Directors. Before moving to Humboldt, she was a principal research scientist at Battelle Institute. Did I pronounce that right? Battelle Institute. Much of her work involves chemical contaminant monitoring and assessment of human exposure routes. She was the lead investigator on a recent food packaging analysis for the North Coast Co-op and advises Zero Waste Humboldt in its public education about plastics. I'm so pleased to introduce Dr. Julie Layshock as presenter this evening.
This is really exciting for me that so many people are interested in plastics, and this is a great platform for me to speak at, because normally when you talk to an environmental toxicologist and chemist, it's only really depressing bad news, because it's our job to identify toxic things in the environment and human exposure routes. But being also on the board of directors for a public education and advocacy group, I also get to talk about some exciting stuff and some solutions and some really great ideas. And so what I want to talk to you guys about today is up here. And so the talk is really going to be broken up into 4 or 5 different parts. And the first part gets at understanding the fundamentals of plastic chemistry. And so, yes, I do teach chemistry, and I can't ever give a talk without throwing in some chemistry, but I promise it won't be that bad. And it's actually necessary. It's necessary because we need to understand the chemical differences of different types of plastics in order to understand the issues, because we can't understand what are the issues of compostability, what are the issues of recycling, if we don't understand what even it is we're talking about. So that's kind of the depressing part, the first half of the talk. So I'm really happy that the students came out and they made that poster, and they're super excited to talk to everyone. Yeah, so it's wonderful. So thank you, Chemistry Club. So you can talk to them some more over the break. And then after the break is where I'm hoping to turn the tables a little bit and talk about some really great ideas that we've been thinking about at Zero Waste Humboldt, and then also share some ideas of other people that are implementing zero waste or plastic-free lifestyles, businesses, or whole communities. And so let's just get right to the chemistry. Okay, so when we talk about plastics, what we're talking about is just a polymer. Okay, and so when I say a polymer, I mean it's just monomers. So we can think of these little blue balls that are all exactly the same, and we link them together, and that's what a polymer is. And so that's what plastics are, just polymers. And so a really common monomer for plastics is ethylene, which just looks like this. It's just a carbon and a couple hydrogens, so that's it. But when we take that monomer now, so that's what the monomer is, or equivalent to a blue ball, and we add it to another monomer, and then hundreds of other monomers, what we get is polyethylene. And so you guys have all heard of polyethylene, right? Probably everyone. Yeah, so this is it. This is the chemistry. This is polyethylene, just a whole bunch of carbons and hydrogens all strung together. And then, they're all mashed up in this tertiary structure. And what we end up getting are 2 different resin identification codes. We get a high density and a low density. The only difference is that packing of that tertiary structure, where the high density means packed tighter, so it's actually a more dense plastic that tends to be rigid, like our shampoo bottles, detergent bottles, where the low density polyethylene, that's kind of like the thin film in those lovely shopping bags. Okay? So here are the other plastic monomers. So here are the other chemistries. And so there's the number 2 and the number 4, the polyethylene. But look at what PVC is. We just take off a hydrogen and we pop on a chlorine atom. Okay, so that's PVC now. So that's the monomer, and we link a whole bunch of those together, and then we get PVC. Okay, PVC is used, we know, for a lot of our piping, but it's also used in food packaging because it's a great vapor barrier. So anything that tends to be like stinky, like, well, I guess it's not supposed to be stinky, but sushi or fish or meat, just highly pungent things, PVC is used as a plastic food packaging. Okay, we also have, instead of putting a chlorine there, if we put a fluorine there, then we get Teflon, our non-stick Teflon. Okay, so that's what Teflon is. Then if we have a kind of a different structure, we have this benzene ring here, we also have some oxygens thrown in. That whole monomer, that makes up our PET. That's what our plastic water bottles are made out of, pop, Gatorade bottles, soda bottles. That's usually resin code number 1. Where if we have polystyrene down here, my personal favorite, we take off a hydrogen and we put on a benzene ring, and now we get polystyrene. Polystyrene as a polymer by itself is pretty hard and rigid, but when we put air into that kind of structure, it puffs up into kind of this cage-like structure, and then it becomes that styrofoam that the trademark name is actually styrofoam. So that's the chemistry of plastics, and so again, they're just monomers linked together in these big chains. Okay? But what about the number 7? You guys have seen the number 7, right? The number 7's a fun one, because what number 7 is it's polycarbonate, which polycarbonate, the monomer for that could be lots of different things. One of them is bisphenol A, BPA. Have you heard of that? Anybody? Oh, yes, it's in the news as an endocrine disruptor, and everything's BPA free now. So that could get labeled number 7. Nylon could also get labeled number 7, or anything that any manufacturer wants to call a polymer and it doesn't fit in any other category is labeled number 7. What's also labeled number 7 are bioplastics. And so really the point here is that anything labeled number 7 can really be anything. Okay? So it's just a generic number 7. Okay, so let's talk about these bioplastics. They're labeled number 7. Not these ones in particular, but these are still what's called a bioplastic. And what makes a bioplastic is that it's made from some renewable resource or some plant source, as opposed to when we looked at these other I'm going to go back here because I forgot to mention it, which is super annoying with the animation, but most plastics are made from petroleum, right? Because petroleum is mostly hydrocarbons, so it's carbons and hydrogens, and so most of these plastics are traditionally from petroleum. So again, super annoying with all the animation, sorry. Okay, so now we're back to bioplastics. And so instead of petroleum, now we're using food crops. We're using corn and sugarcane. And what we're doing is we're pulling out that sugar, feeding it to some microorganisms. They're fermenting it kind of the same way we would if we were going to make some whiskey or something. And we're making alcohol. And then we're basically chopping off the part that makes it alcohol. And what we get is back our ethylene, and then we take those ethylene monomers, link them together, and what we get is exactly the same thing. So no difference chemically in the end. Okay, so bioethylene is still polyethylene. Chemically identical. We have differences in the beginning of life, but the product is exactly the same. We can also have the plant bottle. Has anyone heard of the plant bottle? This was developed by some really awesome materials chemists by Coca-Cola Company. And what they did is they said, okay, well, we're going to take and we're going to isolate the ethanol from the corn the same way we do up here. So this is the same thing, just whoop, down here. And we're still going to get this part from petroleum. And we're just going to link those molecules together because we're awesome chemists and we can do it. And so now we get PET, and now we're going to link those all together, and the product is exactly the same. Number 1, polyethylene terephthalate. Okay, so again, it's called a bioplastic because the source is about 30% by mass of corn, but the rest of it was from petroleum, but the end result chemically the same, and so it gets stamped the resin number 1. Okay, so of course we call this bioplastic, stamp number 1 and number 2. What's also considered a bioplastic, and this is the one that gets that number 7 stamp, it gets the number 7 stamp because it actually has a different monomeric chemistry, and that chemistry looks like this. So this is an example of the most common bioplastic that's sold right now. There are tons of other bioplastic monomers, so this isn't the only one, but this is the most common. And this is called PLA, which stands for polylactic acid. So what we do to make that, not me personally, but lots of companies, one of them is NatureWorks, is they Again, grow food crops, typically corn and sugarcane, pull out that sugar, feed it to microorganisms. Those microorganisms, again, ferment the sugar, but they're a little bit different microorganisms, so instead of making ethanol, they're making lactic acid now. That lactic acid is now our new monomer. And now all that lactic acid gets linked together, whoop, polymer, okay? And so the end result is this plastic that is still a plastic and looks and feels very, very similar and is actually incredibly similar to the monomer that we get for like a high-density polyethylene or a polypropylene. So very similar characteristics, which I'm sure you guys have all seen, these number 7 PLA, and they just look like plastic because they are plastic. Okay, but they're bioplastic because they're derived from a plant source. Okay, this is one thing that people don't like to think about or maybe don't know about. But plastics, I just told you, are these polymers. Yes, that's true. But how we get the whole range of products that we have in our everyday lives, pretty much everything. I mean, this is made out of plastic. I'm sure something I'm wearing, my buttons, they're made out of plastic. We have all these different plastics in our daily life. And to get all these variations, what materials manufacturers do is they add in lots of additives. And so we can get colorants to get all the different colors of plastics that we have. We also add in anti-static agents. We add in antimicrobial agents because we don't want things growing on our plastic. We also don't want them to catch on fire, so we add some flame retardants in there. And there's a whole slew of other chemicals that we can add in there. We add in these plasticizers, which are called phthalates. So those have also been in the news lately for health reasons, right? And so these are actually the reasons. These additives are the reason why we're told don't heat up your food in plastic. Because what happens when you heat it up, it just allows these things to then transfer into your food and beverages. Okay, so it's the additives that are usually of concern, not the actual polymer of the plastic. And note here that I have in this picture, this is a PLA, what the actual resin looks like after it's manufactured. Bioplastics have all the same additives as a regular plastic. And so just because it's a bioplastic doesn't mean it doesn't have all this crap in it. It absolutely does. Okay? And even more so because, remember, the chemistry is just a little bit different than a traditional plastic, so you actually have to add more to make it seem like the plastic that we're used to. Okay? So that's the really depressing news. But it gets worse. Because now we're going to talk about all the issues with that. So now that we understand the chemistry, and we all do, right? We understand the chemistry. Okay, well, we all understand that, different, slightly different monomers all linked together. We have some other stuff. That's pretty much all we need to know to get at the issues here. And so what the issues are is we've created this culture of a throwaway living. We've created a mess. And so whenever I'm walking on the beach, which is a lot because the beaches are beautiful, and there's just plastic everywhere, and in this remote Northern California area, with plastic being strewn everywhere, it's super depressing. And whenever I see that plastic, this image, because I love this image, pops in my head of Time Life magazine. There were these, when plastic was invented, it was invented as this miracle product where there were these huge campaigns, liberate yourself from house chores, women, don't do the dishes, just throw them away. And so this is really how we got into this mess. It really started in the 1950s. And plastic is really not the best thing to make disposable because, as we all know, plastic lasts forever. And we really don't know how long. Maybe it's only 1 million years. Maybe it's only 300,000. No one has lived long enough, so we really don't know how long it will take to degrade. Okay? So that's the biggest problem. And the other issues are there's so much miscommunication out there that's from marketing, that's from industry, and it's really hard for just a general person to figure out what's going on. I mean, until I made plastics my pet project, I had no idea. And I remember buying things thinking, oh, I really want these strawberries, but oh, it's in plastic. I'm not going to get it. Oh, turn it over. Look, it has the recycle symbol. Okay, I'll get it and put it in the recycle bin. But that is a huge, terrible thing because this whole chasing arrows symbol, it was only meant to indicate the resin type or the chemistry. So these numbers just indicate the different chemistries because when you go to recycle a plastic, they have to be separated by their chemistry. And hopefully that makes sense because their chemistries are all different. So we need to separate them according to chemistry. So in 1988, this is the Plastics Industry Trade Association, one of the most powerful lobbyist groups that we have. And they decided, hey, this is a catchy symbol, we're going to use this because we want to help recyclers. So that part's true. They did want to help recyclers figure out the different chemistries of the plastics. But they chose this chasing arrow symbol purely to indicate that this is polyethylene or this is polypropylene. It does not mean recyclable. It just means this is polypropylene, this is polyethylene, this is PVC. Of course, a lot of people are upset about this. And so this ASTM is the American Standards for Testing and Materials. They finally said, okay, enough's enough. We have to change our symbol and make it this solid arrow symbol. Okay, this was approved in 2013. If anyone has seen a plastic lately, it's still the chasing arrows. I have no idea why. That's for somebody else to figure out. But it was approved, and supposedly we're supposed to be seeing these symbols stamped on our packages. Okay, because it's less confusing, more clear, because all it's meant to do is indicate the type of the resin. Okay, so then we have all this new green terminology that's flooded the market as of late, and this is super huge, especially here in Humboldt County, where we all are trying to be as responsible as we can be, and so there's lots of this green stuff around. And it was this slide that got me so impassioned about studying plastics and got me actually involved with Zero Waste Humboldt. Because I remember seeing this polystyrene, which, you know, not my favorite thing. I remember seeing this all green, and I was like, yay, they figured it out. They absolutely figured it out, and oh, look, oxy-biodegradable, that sounds great. Plastic wrap, oh, good, we can just use that now because someone's figured it out. It's green, it looks great, sounds great. But no, this is really all just marketing, and you guys know what the plant bottle is now, right? Okay, just the same thing, polyethylene terephthalate. Okay, so there's all this marketing that makes it super confusing for consumers to figure out what's going on. And so the Federal Trade Commission a few years ago, in 2012, they said, okay, again, enough's enough. There's so many false marketing claims stamped on products, and so they published the Green Guides. And so this has helped tremendously, but it's still confusing and there's still lots of terms. And if you're not constantly keeping up with the changing terminology, and reading this huge document, then you're kind of still lost when it comes to deciphering this green terminology. So that's an issue. And again, with the issue are these terms. So we have bio-based, biodegradable, and compostable. Okay, they all are related terms, but they all mean very, very different things. And so when we see the term bio-based, plant-based, or what's the other one there? Bioplastic. So all that indicates that's just how the product was made. So that's just the source part. That's where we got the materials. Where did we get the monomers? Did we get it from petroleum? No, it's bio-based, bioplastic. We actually got it from corn or sugarcane or some other source. There's actually some microorganisms that can naturally make a bioplastic too if you feed them some sugar. So there's lots of different ways that we can get this bioplastic, but again, it doesn't say anything about the product that you actually made. It's just benefits on the beginning. Okay, there are some benefits when you're talking about plastics and a bioplastic, and that's greenhouse emissions are lower, overall energy consumption's lower to get your source of your monomer from a plant-based as opposed to a petroleum-based. But after that, the product that you made has all the same challenges that a traditional petroleum plastic would have. The term biodegradable means absolutely nothing. Well, I mean, it means something. It means that it can be broken down into smaller pieces or eaten by some microbe. And that's it. There's no qualifications, no whatever. It just means some microorganism somewhere is able to break down that material. No time frame specified, nothing saying that it has to break it down to something non-toxic, nothing saying that it even has to break it down to a molecular level. It just might be, you just take some bites off, I don't know. And so this biodegradable, if you see a piece of newspaper, if you see a piece of cardboard, a plastic, metal, and it's stamped biodegradable, sure, it's true, everything is biodegradable, everything. Okay, so anything, you can just go stamp everything. Everything's biodegradable, but really it means nothing when we're talking about trash. The only one that means something when we're talking about trash and when we're talking about waste is this term compostable. And this is, again, thanks to those FTC green guidelines. And this is a certification that you see on a lot of products now, especially food packaging. Has anyone seen this? BPI compostable. And what this means, this is a third-party certification that they farm out analytical tests to make sure that whatever product can be composted down to humus in 180 days in an industrial composting facility. That is the key word. So key. This does not mean backyard, okay? This does not mean that if you take your bioplastic compostable cup and it flies out of your bag or something like that, and it's floating around in the desert, it doesn't mean that it's going to compost. It needs water, it needs the right microorganisms, it needs the right temperature. It also doesn't mean if that plastic cup, that compostable cup, is floating around in the ocean and that salty cold water, it doesn't mean it's going to compost in the environment. Okay, it has to be very specific conditions. All right, so the situation gets a little worse for us here in Humboldt County because remember, we need an industrial composter to get rid of this compostable plastic, this compostable paper, whatever has that stamp in an industrial composting facility. We need to be able to get that trash to a facility. The only facility, well, not the only one, the closest one to us is this one way down here near Ukiah. So this is just not feasible to ship everything down there. And then a composter, they really don't want it because when you have just basically carbon, hydrogen, and oxygen, you're not giving any nutrient value to the compost. So why would a composter want it? It's just going to, when it composts just to CO2 and water. So you're basically just making some carbon dioxide gas and some water, and that's it. And so there's no real incentive for industrial composters to take this new bioplastic material. And there are some cases where some really savvy festival workers have made special arrangements with Cold Creek Composter to take bioplastic cups that have been at these local festivals, and that's just when they made deals to say, okay, we're going to ship you all of our ridiculously heavy, full of water compost all the way down there, but we're also going to give you our compostable cups. And that guy said, okay, because I'm getting all these nutrients. And so there have been circumstances where people have taken Humboldt County's bioplastics, but it's really on a kind of case-by-case basis. And so now let's talk about the issues with recycling. So again, recycling, due to its different chemistries, it has to be separated. And so how do we recycle now? Pretty much everywhere in the U.S. All in one bin. Okay, so we think we're doing good when we just toss it in the recycle bin and we recycled. But that's not what recycling is. That's just an act that makes us feel good that we recycled something, but that's not recycling. What recycling is, all right, so it's collected, then it gets sorted. Then after it gets sorted into all those different monomer types, all those different resin codes, then it gets baled, then there has to be a buyer. Someone has to buy this stuff. It just doesn't magically get recycled just because we love the environment. This is an economy. People are making money off of this. And if they can't make money off of it because now petroleum's super cheap, they're not going to buy recycled plastics. Okay, so there has to be a buyer for it. Okay, let's just say someone buys it. Okay, then they crush it up into little pieces, and then they have to wash it. So this is a water-intensive process because remember that plastic that has detergents on it, it has soap, it has food, it has motor oil, who knows what is on there. So they gotta get rid of all that because they don't want any of that, they just want the plastic. So it has to be washed, and then the regenerated means you have to remelt it. And then you remelt it into some product that you're going to make, some your recycled plastic product. And so another thing that people don't necessarily realize is that a water bottle or a plastic food container, let's just assume that it can get recycled. So say it gets recycled and goes through this whole process, it doesn't get recycled back into a food container and back into a water bottle. That doesn't happen because, I mean, think about all the stuff that you throw in the bin. There's all those colorants in there, there's all those other additives that are just completely make a muck out of it. So you can't really recycle a product back into the same product if it's post-consumer waste. So what it gets recycled into is like a fleece jacket, gets recycled into a park bench, so it gets recycled once if it gets recycled. Okay, then a lot of times there's problems here though, because now you have all these new compostable plastics that, what do they have on the bottom? That chasing arrows number 7, that's confusing. People throw that in the recycling bin. They are not recyclable, but they're now contaminants to traditional recycling. And so what they do is they decrease the quality of this melt. So when they go to remelt that plastic material, if there's a whole bunch of contamination from bioplastics or for something else, they end up getting a product that's just kind of brittle and breaks apart that they can't use. They can't remold it into anything else. So then it becomes more economics, and that it's not economical if they're getting all this contamination in. And so again, that hurts the recycling industry. And so recycling is a very challenging type industry that's dependent on so many different factors. Which leads to this number. I don't know if any of you guys got that, but it's a very low number, and these are EPA estimates of only 5 to 8% of the plastics that get manufactured yearly, and again, these are estimates that the EPA does, actually get recycled or converted, and so super low. So think about all the plastics that you're throwing in your recycle bin thinking that you're doing a good thing, and then think of that number. Okay? So it's a pretty dire situation of what actually gets recycled. Okay, so again, I gave it this own little slide here because this is really important. These do not go in the recycle bin. They're huge contaminants, not recyclable. Okay, so anything that's post-consumer is not recyclable. This also brings up a good point, though. Of all those other resin codes, everything is technically recyclable, but is it economical? And there are actually facilities to do it. There aren't any facilities that recycle post-consumer bioplastic. There just aren't any. There are some pre-consumer recycling that are the actual manufacturers of this stuff that take industrial scrap and put it back in, and then they recycle it. So there's that, but there's no post-consumer recycling. Okay, that market just does not exist. All right, then we have another issue of the thin film. So the thin film is a huge issue. These are the plastic bags. These are, a lot of you had some thin film. They could be chip bags. It could be the bubble wrap. So this thin film is really a hindrance to the recycling industry. This is what it does. It clogs the machines, causes malfunctions, and it contaminates lots of different resins because they kind of can make their way in there. And so thin film recycling, there's lots of misinformation, and actually I can't even tease it out. But the best way if you have thin film is definitely do not put it in your bin. Save it and segregate it, and then put it in its own bag, and I'm not sure what to do with it then. But definitely don't put it in the mixed recycling because it's just going to run amok with everything else. Yeah?
Well, what happens when you take it to Safeway? I mean, when you take, I mean,
That's an excellent question.
where does it go?
I don't know. I don't know, but what I do know is that plastic film can be bioplastic, so that can be the PLA, it could be polyethylene, or it can be PVC. Those are the three main types of plastic film. They all are collected in one bin at Safeway, and a lot of them are not labeled. So those plastic films, there's no really place to put a stamp. And so from what I just told you about recycling and separating, what do you guys think the odds are that's actually getting recycled then if it can be lots of different resin codes all mixed together? Yeah, I don't really know. So, and this is televised, so I don't want to say that I know and then have someone, yeah, I don't know what happens to it. Don't know. Okay? Then there's this issue where, again, we have amazing scientists out there. Really awesome materials are being developed for food preservation, for advertising, but they're really awful things. They're awful because they're what's called mixed resins, meaning lots of different material types. So there's some really bad ideas when it comes to thinking about disposal. Great for, again, food preservation and for convenience sake, but these guys are all what's called mixed materials. So a coffee cup, this is paper. What could be so bad about that? Well, if it's water resistant, it's not paper only. The outside's paper, but the inside is coated with a thin layer of plastic. And so this is what we mean by a mixed resin. It's paper and it's plastic. That means you can't recycle it, you can't compost it unless it's stamped BPA compostable. Then it could be in an industrial composter, but you first have to find one of those that will take it. Okay, then you have these chip bags and the Tetra Paks. They are even more interesting because not only are they plastic and they can be paper, but they also have metal mixed in too. And so they're these very thin layers of materials that are all chemically bonded together. And so what that means is all of this stuff is just trash. There's no other disposal option for them. And then these are very, very stable products because they're made to keep things fresh for many years. I don't know how long, but probably a really long time. And so they're going to last in the environment for a really, really, really long time. So they're really disposable products made for one use, and then they're going to be here forever. And
Can I just ask, are you talking
yes.
here about like soy milk and almond milk containers?
Oh yes,
Is that
yeah,
what you're trying to
yeah.
say?
So these, like chicken stock, vegetable broth, soy milk, hemp milk, those are the products, yeah, that come in that Tetra Pak. Coconut oil, or coconut water, that comes in those as well. Okay, yep, those are the packs. Okay, so now let's be even more depressing. Remember, we're still on the depressing, we're still on the issues. So when we talk about our waste, so I'm so glad, Maggie, you brought up, when we should just say it again now that this slide's up. When is the meeting for the Eel River disposal? So the city council meeting is this Wednesday at 6 p.m. And you can check the City of Arcata's website for the agenda to find the exact time that that agenda item or the recycling will be talked about. So that's important because currently now, what our waste does, where our recycling goes after we put it in that recycling bin, it gets shipped to the solid waste, or it gets shipped to Willits through the company Solid Waste of Willits. What they do is they sort it and they bale it and they try to find a buyer. They're buyers. They have some typical buyers that they sell their goods to. Those are all companies that are in China. And so their companies are located in LA, and then our recyclable materials get shipped out to China. So that is the current route. But again, the market fluctuates. So if it's not economical, then these companies are not going to buy it and they're not going to ship it to China. They're probably just going to throw it in the landfill. So again, it has to do with economics. But know that if your plastics are getting recycled, know that they're getting recycled over in China because that's the main buyer from the Solid Waste of Willits. And so it's an important conversation to have about recycling in our remote location here, is that we really need to get a recycling facility here that once used to be here that can segregate our recyclables, and so we can maybe start to recycle them locally and keep resources here. So, okay, now we'll talk about more about that on the solutions part. And so the landfill is not much better. And so this is a North Coast Journal article that was published last year, and I highly recommend you guys to read it. It's completely fascinating. So anything that's going to the landfill, we don't even take care of that here. So a huge carbon footprint for all of our waste that we're generating in Northern California. It's crazy. The North Coast Journal said, I think it's 8 semi-truckloads are being shipped out every single day to take care of our landfill waste here. You have to check the exact article to fact check me. But anyway, our trash either goes up to Medford, to Anderson, or down here to be landfilled. So we don't even take care of it here. So an amazing environmental footprint we have just to get rid of our trash. And our trash should be considered a resource because there's lots of value in that. Okay. And so again, we're just wasting resources here with all this trash, and then we have all this confusion. So say we do have some compostable material that ends up in the trash. Our compostable plastic ends up in the compost or the recycling. I mean, you guys know the story. It's just a mess in the end. Okay. And so now we're just going to leave it up to you guys. We could take a break. So that's the bad part. Did you guys want to see how you did with my game? Which, by the way, thank you very much. Do you guys want to break now, or do you guys want to see how we all did as a community with dealing with our plastic? Okay, well, we'll see what we did. Would someone please bring up those bags? That would be lovely. And we'll talk about all that trash and see if you guys put it in the right bin. Who thinks that they put it in the right bin now after they've heard? Okay, who thinks that they put it in the absolute wrong bin? Well, no one thinks they put it in the wrong bin. Okay, maybe you guys all did great. Recycling is coming up first. Okay, recycling is a tough one because remember what I just told you, there has to be a market. Yeah, I got it. Okay. So we're going to talk about the recycling first. Yeah, you guys can just put that there. Just put that there. That'd be great. Thank you. So, okay, we're going to talk about what you guys put in the recycling. Thin film, no thin film, that just runs amok. Okay, so if we segregate it, then it might be okay. This is a mixed material, it's plastic, and paper. And so what makes it water resistant is that it has a lining of plastic. And so this is the, this is the segregated recycling pile. And we'll do this is just this is the actual recycling. And then we'll do this is the trash right here. So this styrofoam, although technically recyclable, meaning that there are places that do it, to my knowledge, we don't have any mechanisms to get our styrofoam anywhere. Is that correct? That's correct. Okay, recycling expert. So this trash for us, this again, what does it say? It says number 2 and number 4, so it's all polyethylene, but it's, even though it's the same chemistry, the fillers could be different in there. That's why they have different resin numbers. Okay, so actually I don't know. I would say trash though. Do you know?
I think that's magical recycling.
Oh, it's magical. Okay. Another styrofoam. Nope. Trash. Okay, let's see. This is this could be recyclable. PET number 1. So this one's correct. We'll keep that one in there. This one says PET. This was actually when I bought my clicker. How terrible. Terrible. But I save things and drive my husband crazy. Polystyrene. So this is PS, polystyrene. So that's styrofoam, but just not the puffed kind. And so this hardly ever gets recycled. So again, technically recyclable. I'm sure someone recycles it somewhere, but I'm going to throw it in the out pile because there's really not a market for it that I know of. Oh, that's all right. We already did that one. And again, this is going to be trash because again, it's a mixed resin. It's paper and plastic. So we're not going to recycle that. And this is a number 5 polypropylene that has a decent market to my understanding, so we're going to keep that in there. And now we have this. We have some plastic. It's not labeled. We don't know what the resin type is. We could probably guess. But do you think people are going to sit around and guess? No. So this is going to go in the trash. Okay, so now we have our recyclables and maybe our recyclables, but we're going to separate them. And we have our trash pile. Now let's look at the compost. Oh, this is actually a great one. So I don't know what this is. I got some lettuce in here. And I heard that it was a bioplastic, but I soaked it in hot water for a while and nothing happened. And so I don't really know what this is, but I'm guessing that it's not compostable. It could be, but I don't know what it is, so I'm going to throw it in the trash. Okay, now we have this guy. This guy's paper and plastic, and I know that because it's for soups, and I also know that because it says it's made from a biopolymer in GEO, which is PLA. So this has the bioplastic PLA, and does it have a compostable stamp? Well, it says it's renewable, it says it's sustainable, it says it's compostable, but there's no certification, so I actually don't know. But we'll just go ahead and give the benefit of the doubt that they're not lying here. This is just paper. So yes, that is. Oh, a Tetra Pak. This is the mixed resin. So this is plastic, this is metal, and this is paper. So, trash. Okay? And here are our bioplastic cups. Okay. So, all of this compostable stuff, bioplastic cup, stamped compostable. So this little strip of paper is the only thing that's backyard compostable. Okay? This little strip. That's it. This stuff now will probably be compostable in an industrial composter. But again, we don't have one here. So this is going in trash in Humboldt County, so we're just going to be Humboldt County here. So this is all going, oh, actually, no, we'll keep this. We'll put this in our backyard compost. Okay. All right. This is fun. All right. So now this is the trash. All right, so yeah, we got some plastic film in here, and quite honestly, I would probably put it in the trash too, but let's just give ourselves all the benefit of the doubt here, and we're going to segregate it like good people, and we're going to put it somewhere. And so this is Stumptown Great Coffee, but they put their product in a paper, and it's lined with plastic. So yeah, this is trash. Tape, I don't know what that is, so that's trash. the compostable cup, whoever did this, very good, because here it is trash. So we're going to put it in the trash. Wait, no, I have the trash. So this is all trash. Okay. And then we have, yeah, this cup is pretty much trash here. If we had an industrial composter, it would probably compost in there. Okay. And so then we have one little package left. And this is a really neat local product, and it looks super gross. It was deodorant. And I used it, and I thought it was a great product. And it's made from just paper. There's no plastic. They're made in Crescent City, but you know, none of our stores here carry this. Okay, but this is actually backyard compostable. I think, I haven't tried it, but they said they don't have any plastic and it's just paper, so I'm going to trust them. So I'm going to put this in our compost. So now we have 2 compostable things, and now we have all this trash. Plastic is really a contaminant to paper recycling. And then also these bioplastics that people are buying thinking they're doing the right thing, which is 100% reasonable, because I once purchased them for a big event because I thought they were the greatest thing ever at one point too. But they're super expensive, and that cost is being passed on to the consumer. So here in Humboldt County, we're just paying more to just throw stuff away and waste some food crops in the process. Okay, so let's go ahead and take a break, and we can all talk, and then we'll reconvene with some solutions. Okay, thank you all. The second part of the talk is really about solutions, and these are solutions that are kind of a compilation between things that we've been thinking about at Zero Waste Humboldt. And there are also lots of things that people here in our community have told me or have told Zero Waste, and then what other people have been doing. And so the first thing to do really is, I'm not against plastics, I'm just against disposable plastics. There's really no need to have anything that's disposable be made of plastic, and we really need to move towards this. And so we need to start as a community, as a whole society. We need to really start thinking about other options. And there's lots of ways to avoid disposable plastic. We just need to make a commitment to do it. And so there's things on the personal level that we can do. We could simply just avoid and stop buying it. We as consumers have an amazing amount of what's called purchasing power. So if we just stop buying it, people are going to stop selling it. It's as simple as that. Okay, so we just all have to start doing that. And then what I would love to see here, and this came from Maggie Gaynor, is she's like, why aren't restaurants asking? You know, they always ask, do you want a box for that? Why aren't they asking, do you have your reusable container today to put your to-go food in? And I feel like all you have to do is just train your staff to ask people that. So if you're a restaurant owner, just train your staff, and I bet 2 or 3 times that you get asked that here in Humboldt County, you're always going to have some container with you. And how cool would it be for Arcata to be the first community that has no takeout packaging? I mean, even taco trucks or food trucks can do this. They can say, hey, do you want that in your reusable container today? And then, it's just done. So let's set a goal. 1 year from today. Okay? And so also buying... Buying bulk is another way. I know a lot of you do this, and there were some really great ideas that came out of the co-op membership meeting. Make bulk super sexy and attractive. Put all the bulk sections right in front of stores. Put it right there. And then another good idea, I don't know where she is, but another good idea, there she is, that I heard is a huge thing against bulk, why people don't like buying bulk and why stores are against it, is because there's contamination concerns, there's the free sample concern, there's people bringing in their own dirty container concerns. I mean, there's so many. Why don't you just have staff man the stations and have consumers come in with their reusable container, or have the store have returnable containers, and then the grocery store staff actually fills up the bulk for the people. That would just eliminate everything, and it would be awesome, and it would really promote buying bulk. I feel like you guys probably already know these things, but for the people that may be watching it later, I'm just going to say it. A way to avoid lots of food packaging, so this thin film on the food, is to eat seasonally. So we don't have to have strawberries all year round. It's such a special treat if we only have them when they're in season. And then work with the farmers. If you are a small restaurant owner or a small business owner, demand that that farmer provides you your produce in a reusable crate. If you demand it, and if every other restaurant owner gets together and says, we want to buy from you, Mr. Farmer, but we want you to give us a reusable crate that we then return back to you to provide our food, that would be awesome, and that could totally go over here. I think everyone would be on board. Then there's this. So this, the Arcata Co-op does this. They put on classes every few months. There's some local experts to make your own body products. A lot of the packaging, if it's not coming from food, it's coming from personal care products. We can make our own stuff. Everyone doesn't need to smell like a new car all the time. And that, I'm glad you guys laughed, because that's actually not my line. That line, though, has stuck with me since I was a graduate student. I was listening to a talk from an ecotoxicologist that studied stream health and contaminants in the streams, and that was his line. And I can't remember his name, or I would credit him, but I do remember what he looked like, and I do remember what he studied. And he said that because there's all these different chemicals out there that we think that we need and we don't. And we should just really all think about what we actually need for personal care products, and then take this class that's coming up on March 6th on how to make your own deodorant, your own lotions, your own, I don't even know what she does, lip balms, but there are lots of really cool local experts. Students can do this on campus. So lots of great solutions to avoid that plastic packaging on a personal level. Then something that we've been working on, and this started with the North Coast Co-op over the summer, we've been doing Zero Waste Humboldt, a lot of research on food packaging materials. And so here are the main food packaging materials. The one with stars are backyard compostable. And so if we can't get to a place where we're just eliminating all of that plastic packaging, then maybe we can use a bridge and use this at least backyard compostable packaging. And so a lot of this backyard compostable packaging, such as the bagasse, is actually made from waste materials. And so after they press out the sugar, they're using the stalks as the fiber. And so that's a really good thing. And a lot of these aren't lined with the plastic, to my knowledge. And so these are good options to get something that's actually backyard compostable if you have to go disposable. And if you have to go for a plastic, at least go for a plastic that has a high rate of recyclability, or actually has a market, or a high tendency to be recycled. And these are things like the #1 resin, polyethylene terephthalate, or the polyethylenes and the polypropylenes. Then on top of that, and this goes to keeping it local, if we're going to choose to use plastic in this community, we need to really start segregating it, or we should start segregating it, and then find a local person. Or if you have these business ideas, start a business to recycle stuff locally. I mean, this is how Fire and Light was born, right? To recycle local glass locally. And so we could do the same with plastic. Here are 4 Northern California recyclers. And so if you're a big business, a small business, and you know that you just can't get away from using polypropylene, collect it yourselves, segregate it, and make deals with those local companies. They might even pay you for that material, okay? I mean, there's lots of really cool ideas that save the planet and save money for everyone, okay? Oh, and the ones with the stars, yeah, are the ones with are the better types of plastic if plastic must be used. Then at Zero Waste, I was hoping to get to a point where we could demo this. We're doing an online decision-making tool, and Fortalinia Software Systems is helping us do this, where we want this to be an online application where you say, okay, I have some hot food. I need to find a good option for a fork, or a good option, oh, you can't read that at all. But anyway, it's a web page that you're going to be able to search for different material types according to a whole bunch of sustainability parameters, such as recyclability, compostability, recycled content, so on and so forth. And so that's something that we're working on at Zero Waste Humboldt, so stay tuned for that. And then I wanted to share with you some really cool ideas and to tell you that it's possible to go zero waste, or not to have any waste going into the trash. And so this is an example of a restaurant in Chicago. I mean, this is Chicago. We could do this here. I mean, they are getting 75, I feel like that's not the right number, but it's some really high percentage of their food locally in Chicago. Why can't we do that here? We could definitely do that. And he is following these 5 R's, where he's first refusing anything coming into his restaurant that he knows that he's just going to have to throw away. And then he's reducing, so he says, okay, I can't avoid this packaging, but I'm at least going to try to avoid it as much as possible, and I'm going to try to figure out things that are actually recyclable. And then he's doing this reuse thing, where one really cool thing that he's doing is any condiment glass jars, he's giving them to his customers, and they fill up their food waste and they bring it back, and then he's composting it. So it's really cool things that people are doing to go zero waste. So I encourage you to look them up. It's called Sandwich Me in Chicago. Another really great idea for a zero waste restaurant, this is in the UK, it's called Silo Restaurant, and they're doing some really, really amazing things where they are making everything themselves. They're even churning their own butter, grinding their own flours, they're doing everything. So 100% zero waste restaurant, and they of course demanded that all of their food suppliers give them their food in returnable containers. So it's all returnable crates, urns for liquids or whatever, but they're giving all of their packaging right back to the producer, who then gives it right back to them. And so really cool thing, this is my favorite, and I'm sure there's a couple people in the audience that think this is super cool too. So what this restaurant did is they purchased an anaerobic digester, but they have so little food waste because they actually take a lot of their food waste and they ferment it to make really cool vinegars and elixirs, and I mean they just try to reuse everything that they have in their restaurant. But what does go in there wouldn't meet the capacity for that restaurant, so they opened it up to a community thing. So now the community brings their food waste to this restaurant's digester, and it creates this awesome community feel. And so really neat things that people are doing, lots of really great ideas, and again, if you're interested in this, I encourage you to look up Silo in the UK. And again, I mean, we could do this, we could do this. We could totally do it though. Would you like this in your reusable container and limit food waste and food packaging? So I also wanted to show you some ideas of some grocery stores. So this is one in Austin, Texas, in Germany, and not a company, but a grocery store. And they do some really cool things where they're also zero waste packaging grocery store. Everything is in bulk there, but they also made a thing that said, we're not doing any big brands. No name brands, it's all local farms. And so there are lots of grocery stores that are doing lots of great things, that have great ideas. Some of them we could easily do here, some of them probably don't apply here. But the point is that we can start thinking about this and we can do it here in our community. Okay, so those are ideas for individuals or businesses, and now these are more on the community level. And so on the community level, we all need to start thinking about how we can basically eliminate everything that goes in here and reduce everything in general. So reduce the amount that's going in the recycle bin, reduce the amount that's going in the compost bin. And so these are big ideas, but there are ideas that need to happen on the community level. And so the first one is we really need to work with our local farmers. We have some really, really amazing local farmers, and I'm sure they would be on board. Everyone wants to do the right thing. And so they would be on board if people start asking them, hey, do you think you can switch those cardboard boxes that I just shipped to recycling? Do you think you could switch those to reusable crates? I bet you they would. If enough people asked, I bet you they would do it. And so we just need to start asking as a community. And if you're a business owner, a restaurant owner, get together, brewery, winery, get together with all the other ones and think about who are we buying from, and start to ask those questions. What waste can we eliminate and what waste can we demand that our suppliers what waste can we demand that they eliminate from our suppliers? So there's lots of different things that could happen. This one, to me, I don't know why Arcata hasn't done this, but this needs to happen. I know that there's been pieces in place for about 10 years. Our local expert raised their hand. Embarrass you. There you go. So she knows all about this, and a lot of people know all about this whole issue, and I think there's been lots of discussion and lots of funding and lots of it's not going to happen, it's going to happen, but it should happen, that we have one of these industrial type facilities to handle our food waste here so we could get those resources and put them back on our farms here. I think that would be wonderful and a great solution to eliminate waste. And then again, this goes back to getting involved in the politics of it all. I mean, it's completely uncomfortable to do it, but we really need to do it. We really need to push to get segregated recycling back here. Okay. And then also, new businesses should rise up. There's so many creative people that want to stay here, but lack of jobs. There's so many new businesses that could start up from this. This is an awesome documentary that, are we going to do a screening of this, Maggie?
Yes.
Okay, so we're going to do a screening of this. Right now you have to pay for it, and it's really great. And it's this guy that travels all across the country, and he's interviewing people from all over the United States that have made a small business solely on reused materials in the community. So they are people that are gathering local trash and making it into something great, or they're just, say, maybe a furniture store that's kind of like a thrift store but a little different, and just lots of great ideas. And so we have two, we may have more, but two that I'm aware of in Humboldt County, Scrap And then rows. These models work, but they're very specific. One for office supplies and one for more of an artsy supply store. We could have tons of these stores for everything. We could have recycled lumber store from all the structures that are falling down everywhere. Someone could go take those and mill them and sell them back. I mean, the ideas are endless. There's so many opportunities here for reuse.
There's a recycling market development zone in the North Coast here, and we have technical assistance, small, low-interest loans and larger ones. And I will help you if you want to develop a business in any way, shape, or form. We had a building resupply place, it was closed down, almost came close to restarting it again, and it needs a little bit more work on that. So if someone wants to work with me on that, I'd love to work with you. So there's lots of ideas, and I do want to say this Friday at Marsh Commons, there's a presentation on the recycling market development zone. So
very nice.
at 6 o'clock. What's that?
Where can we contact you?
Oh, thank you. My number is 707-407-8335, or rmdz@sonic.net. Recycling market development.
So the point is here with this slide is that all of our trash currently is being shipped really far away, and they're all resources that we can use here, and we just need to find creative local solutions for it, and we can do it. And if I wasn't going over time so much, I would ask for people to say what they're doing, because I know lots of people are already doing that in this community, but there needs to be more of it, and there needs to be more of those ideas being shared. So maybe if we have time for it, we'll do that in a second. I only have a couple more slides. And so I just want to give this one example. Has anyone heard of zero waste communities? So whole communities that are coming together and they saying, we are eliminating all of our trash altogether. This is one example in Japan. And they did something really radical where they used to burn all of their trash. They used to incinerate it. And they just decided as a community of around 2,000 people that they were going to go zero waste. And what they did is they made residents, they stopped their single stream recycling, and they made residents actually wash and bring in and sort out for themselves all of their recycling. So every resident needs to sort out their recycling. And so it's a whopping 34 categories that people need to separate their trash. And so at first you could imagine that this was met with a lot of resistance, and it was in Japan, but the community there love it, and they say it's just normal for them now, and it's great. And then everyone's trash has gone way down, because once people actually see for themselves how much they're generating on a weekly basis, it causes people to think, oh, I had no idea I generated this much trash. And so it's a really good idea to segregate, and the single stream is probably not the best idea. And they also, out of this and the whole reuse thing, a number of new businesses popped up to recycle local materials. They've also initiated at their recycling facility a drop-off and pickup. And so it's kind of a trade thing. So say you have an old washing machine that it works, you can take it there, and if someone needs a washing machine, they can just take it. So it's a totally free thing, and it's a huge way to build the community. And so there's lots of other zero waste communities that are going through this. And so just if you're interested, just Google zero waste community. Tons of great ideas. And again, some ideas may not work here, other ideas may work great. Okay, so that's all I wanted to talk to you guys about, and I just wanted to leave you with the new 5 R's. So the old 3 R's, they're out. These are the new ones, and they're follow them in order is what it is. And so the first thing is refuse, the second is reduce, reuse, and recycle is all the way down here. So recycling is still a great thing, but it should be towards like the last option. Then of course, whatever you can't reuse, then compost. And so we have lots of other solutions, and you can find those at Zero Waste Humboldt, and you can probably get in touch with Maureen through our website as well. And so first of all, I want to really thank you guys. You've been great, and if we have time, I would like to hear how your business or you are helping reduce plastics. Both good questions. The first one was about cellulose, and can I talk about that? Cellulose is still a polymer of plastic, cellophane. Yes, cellophane is cellulose, so it's made from a plant, and it's still a polymer. And to my knowledge, it acts like a traditional plastic. But I could be wrong on that. But it is made from cellulose, so it's made from plants, but it's still a plastic polymer. And then, what was the second question?
I was wondering if the bioplastics
Oh, can the bioplastics be dissolved in or be broken down or composted in a digester? I think it depends on the digester, it depends on the temperature, and it depends on the length of the cycle. Plastics were actually invented because of foreseeable shortages to petroleum, not for a green compostable alternative. It was kind of just a side bonus, I guess, that they happen to degrade more readily. And so research into bioplastics really came from we need to find another solution from petroleum, but there's been lots of studies that have done assessments where they say, okay, this is how much plastic we use now that we get from petroleum. Is it even possible to completely replace all that plastic? Do we have enough corn and sugar? And what do you guys think? No. So we couldn't even do it. And so, yeah. So the question was about what rigid plastics does the dump take, and it was number 2. High-density polyethylene was the answer.